Today we're going to use the 3 steps to sketch method to graph a basic tangent graph. So we'll be looking at y equals tangent of 3x. Let's get started. So we have our outline of the 3 steps to sketch method. We'll find our essentials, plot our key points in our pattern, and then we'll sketch a cycle and repeat for as many cycles as we want. All right, so let's dig in. Step 1, let's start by finding A and B. And remember, these fall into that basic general equation, y equals A tangent of bx. Okay, so that's where you know to look. So in our equation here, we understand that there's a 1 in front of our tangent, so A is 1. And we see that the coefficient in front of x is 3, so our b is 3. And remember, b is special here. It tells us how many cycles of our graph should happen between 0 and pi since it's tangent. So we should see 3 cycles happening between 0 and pi. And that's just a great thing to keep in the back of your mind so that when you finish your sketch, you can check, okay, does that match? Is my graph accurate? Okay, great. So now that we have A and B set, we know that we can find the period. And for any tangent graph, you simply calculate the period by taking pi and dividing by b. So in this case, our period is pi over 3. All right. And then the next thing we'll want to find will be our scale labels. So for our method, we like to do the horizontal scale labels, and this is what we'll label our tick marks. All you need to do is take the period and divide it by 4. That'll ensure that each of your main points lines up horizontally with your tick marks. All right, so instead of doing pi divided by 3 divided by 4, which can get confusing, I like to multiply by 1/4. It does the same thing, but it's just a little cleaner to look at. All right, so multiplying across, you see that your horizontal tick marks should be labeled by counting by pi over 12. All right. And then finally, our vertical labels, we usually can just use A, so we'll do that here. All right, and that'll ensure that those midpoints that kind of set the curve will be lining up nicely. Okay, finally, asymptotes. So remember, we can find our asymptotes by using a formula, and I'll just write that formula out. It's x equals pi over 2b plus pi over bk. All right, and this works for simple asymptotes of tangent, so let's go ahead with that. We know our asymptotes will happen at x equals pi over, so 2 times b, that'll be at pi over 6, plus pi over 3k. And that's where k is an integer, and this is the shorthand I like to use for that. K belongs to the set of all integers. And that just means that you can find a particular asymptote by substituting in k is 0, or k is 1, or k is 2, or k is -1 or -2, and so on. And you would just simplify and know the location of that particular asymptote. All right, so that's how we can find the asymptotes. And you'll notice that with this method, your first positive asymptote should always line up with your second horizontal tick mark. And that's a nice double check to have as well. One note about this before we move on, there's another nice trick to finding asymptotes of tangent, and this will work for simple tangent equations, but also more advanced tangent equations. So all you have to do is take, and I'll do this up on the top right of the screen, all you have to do is take all of your horizontal transformations, so that's everything that's happening in the input of the tangent function with the x, and you can set it equal to the parent function asymptotes, so those of just plain old tangent of x. And then you'll solve for x. So we would just do 3x equals pi over 2 plus pi k. And we know that pi over 2 plus pi k are the asymptotes of tangent of x. So really, you'll just be applying the horizontal transformations to the asymptotes algebraically, and this can get you that equation of the asymptotes as well. So if you don't like formulas, this is a great way to do it. And like I said, this way is also really great for much more advanced graphing of tangent equations. All right, so back to this, we would just divide everything by 3. Divide by 3, divide by 3. And so you see you would end up with the exact same equation that our simple formula got us. X equals pi over 6 plus pi over 3k. So either way you like to do it, I'm personally a huge fan of the setting the transformations equal to the original asymptotes and doing the transformation that way because it works every single time. But if you like the formula, go for it, use the formula. One more note on this, the plus pi over 3k, that tells you that the asymptote happens once a period. And just knowing what the graph of tangent looks like, that makes sense. We have one asymptote per period. All right, so before we move on to step 2, let's go ahead and label our axes. So we'll start by labeling our horizontal axes, counting by pi over 12. So just count 1 pi over 12, 2 pi over 12, so that reduces to just pi over 6. And I like to stop here and say, okay, does that make sense with my asymptotes equation? We see it does, because if you let k equal 0, your asymptote that comes from that is at pi over 6. So again, that second tick mark should give you your first positive asymptote. Okay, so back to it. We counted 1 pi over 12, 2 pi over 12, 3 pi over 12, which also reduces, and 4 pi over 12, which reduces. This fourth tick mark as we move to the right should always match your period, because remember that the period is just the horizontal length of one cycle, and we know that our pattern comes in 4s, and so our fourth tick mark should be the start of a new cycle. Okay, and you could keep going if you wanted. So we stopped at 4 pi over 12. You could keep labeling 5 pi over 12, and so on. All right, let's label the negative part of the horizontal axis. So it's all the same. We are just labeling with negatives. All right, we have negative pi over 3, so that's a good benchmark for another cycle, and negative 5 pi over 12. All right, so that was the harder part in terms of labeling. And the vertical axes, we're just going to count by 1. So 1, 2, 3, negative 1, negative 2, negative 3. All right, so we've done a lot of prep work in step 1, but we really feel like we've dug into this equation. We know what's going on. We know what to expect. So steps 2 and 3 should really fall into place. Okay, so step 2 is to plot the key points. So I like to think of this pattern as 0, midpoint, or curve setting point, asymptote, the negative version of the midpoint or the curve setting point, and then you will start repeating. You'll get back to a 0. And we know tangent that is not shifted should start at the origin. So we'll plot our first point. So 0, the positive curve setting point, because this is not a reflected graph of tangent. Our asymptote, the negative curve setting point, or the negative middle point between 0 and asymptotes. And then that's the finished pattern, but I like to go ahead and plot the next point in the next cycle at pi over 3, 0, just so we have something to sketch nicely with. So let's go ahead and just put a point there. Okay, so that is one complete cycle. Let's go ahead and move on to step 3 and sketch it. So we know our tangent curves from the 0 through that curve setting point, follows along the asymptote, jumps, comes back from the asymptote through the curve setting point to the next 0. So this is one full cycle of tangent. I like to call this a split cycle just because instead of a smooth continuous curve, you have the upper half asymptote and the lower half. It's just a nice name, a nice way to refer to it. Okay, so that's one cycle of tangent. Let's repeat. Let's do just one more cycle, and we'll do that on the negative part of the horizontal axis. Okay, so from where you started the green cycle, count 1, 2, 3, 4 to the left, and you'll see that you'll start your repeat cycle at negative pi over 3, 0. So you do 0, positive curve setting point, asymptote, negative curve setting point, and you can sketch that in. Okay. So one quick note on this asymptote right here at negative pi over 6 can be found if in your equation, look back at this asymptotes equation, that's if you plug in k equals -1. So you can actually calculate that. We have x equals pi over 6 plus pi over 3 times -1 is k. And so with a little bit of calculation in common denominator, you see that this turns into negative pi over 3. We want a common denominator of 6 so that we can simplify. So you'd have pi over 6. Here this would be rewritten, and I'll do plus, rewritten as negative 2 pi over 6. That's the same thing as negative pi over 3. And you see that gives you negative pi over 6. So that is the asymptote that we just graphed. And it's nice to really get a good feel for how the asymptotes equation works. I do think sometimes that's the hardest part for a lot of people when graphing is working with those asymptotes. But once you really get it down and you understand, well, all you have to do is substitute in integers for k to get different asymptotes along the pattern and along the graph, it becomes very, very easy. All right, so if you wanted to graph more, of course you could. You would just keep going with the pattern. So you see there's a point at 5 pi over 12, comma 1. So your graph keeps going like that. You could put a point at negative 5 pi over 12, -1, because the graph we know comes down like that. And if you had more space, if we had more space, we could keep going. So two other quick comments. One, if you look between negative pi over 6 and pi over 6, that's a full continuous cycle of tangent. So between the two asymptotes, you can see it's uninterrupted. So versus the split cycle we talked about earlier. That's just a nice thing to notice. And then the final thing I would say is go back to B, and we know B is 3. So of course we did not graph more positive cycles except for just a little bit past pi over 3. But hopefully you can see if we were to keep going, we have our first cycle that happened here at pi over 3. So you can imagine another one would happen in another pi over 3. So that would be a second cycle at 2 pi over 3. And a third cycle would happen between 2 pi over 3 and pi. And so that would give you what we know B tells us is how many cycles happen between 0 and pi. So hopefully this helps you graph tangent of 3x, and you can apply all of this to any unshifted tangent graph. All right, so check out more on 3 Steps to Sketch, and good luck.